Hey everyone, thanks for joining us for the next episode of our Spotlight on GitHub Advanced Security series. My name's Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to review our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional, and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer live. Our session is being recorded. It will be available to view on demand right here on the Microsoft Reactor YouTube channel. With that, I'd love to turn it over to our presenters for today. Thanks so much for joining us. Hey, Jeff, you are muted.
Hey, thanks, Anna. Welcome, everybody. We are very excited to be here. Could you show the first slide for us, please? We're going to be talking all things application security today. Talk about a comprehensive DevSecOps program that you can put in place, leveraging the GitHub solution. So just as a way of introduction to myself and Tom, so my name is Jeffery Payne. I'm the founder and CEO of Coveros. We'll talk about Coveros in a bit. I've been building and testing and securing software for 30 plus years. Have run a couple of consulting companies focused around application security and DevOps. Tom, do you want to introduce yourself?
Yeah, hi, I'm Tom Stiehm. I'm the partner and CTO at Coveros. I help organizations improve the value they get out of their software delivery through helping improve processes, including application security processes. Thanks, Jeff.
Thank you, Tom. So just as a real quick introduction, Coveros helps build critical software faster. So we help organizations that have regulatory requirements in their software development process address those issues, whether they're safety, security, reliability challenges, to also accelerate delivery, but while meeting regulatory requirements. We have 4 lines of business at Coveros, a very strong consulting practice around agility, delivery, achieving automated governance and regulatory compliance. We also roll up our sleeves and do hands-on support with our customers as well. We also do lots of training. We have 50 plus software training classes. Many of them are certification trainings that cover everything from Agile and DevOps, across leadership, across fundamentals, across engineering. We are also a GitHub Premier partner and a Microsoft partner. So we have certifications in those areas as well. Our third area is software conferences. We run 4 leading software conferences a year, including one in Canada, Star Canada, 2 testing conferences in the US, Star East and Star West, and our AI conference, which is going to be held in Seattle this year in June. We also have some free online communities for software professionals to help leaders and professionals share and collaborate with each other. Sticky Minds is our long-running software engineering community. Women Who Test is a community for software testers who are female. And our Software Leadership Council is a leadership-oriented community for anyone in management or leadership or who strives to move in that direction. So our agenda today, we're going to talk all things application security. First, we're going to start with some challenges and then talk about some common tools that are available for application security, where these application security tools fall short, and how you can leverage GitHub to improve your application security across the entire SDLC. We will also do some demos, show you some GitHub tools in action, so definitely stick around for those. So let's start with the challenges. Here's some stats from some recent reports on application security, and the results are pretty sobering, quite honestly. Having been in this market for 30 plus years now, it's striking where we stand today. 8 of the top 10 breaches in 2023 were related to application attack surfaces. The percentage of apps with high severity flaws continues to increase year by year, and the time to fix those flaws continues to increase year over year, which is a little depressing. Major coding changes, only a little over 50% of major coding changes are being put through a full security review before they go out the door. And half of organizations have critical security debt coming from a variety of places, including third-party code that they are integrating in through dependencies. Financial services, insurance, healthcare, they tend to have the highest number of critical vulnerabilities. That's a concern, obviously, because of how critical those applications are. And 70% of critical issues take 12 hours or more to resolve, which is tough if it's a critical issue. So, Tom, let's talk about this a little bit. What do you think the major reasons are why we have these challenges still in application security?
I think there's a number of reasons. One big one is that the AppSec landscape's ever changing. New things are found all the time. Scripts are created to exploit them, and it's hard to get in front of them. Then the other thing is that a lot of teams are driven by creating new features. New features are often the thing that sell their products and services. And so we tend to put AppSec at the end of a release cycle, and there's no time to remediate all the issues we find. So we often find we negotiate security vulnerabilities into production with the promise that we'll fix them soon. Sometimes soon never happens.
Yeah, those are great points. I know we always say that it's an arms race, right? To your first point, every time you come up with approaches and ways to mitigate risks, new risks and issues are identified that you have to get on top of. So it's a continuous process. I agree. That's difficult. And you and I both know that we have lots of customers who have large piles of known vulnerabilities that have been pushed into production. And we've actually been brought in sometimes to kind of work that backlog, if you will, down. But those are definitely issues. But it does seem that things are actually getting worse. Why do you think they're getting worse right now?
I think it gets down to complexity. The environments that we're operating in, creating applications that are meant to live on the network, lots of dependencies with third-party and open source products, just brings in a lot of complexity, and the application security attack surface just keeps growing. So it makes it hard to cover it all, and then it's hard to understand what all the problems are because of the complexity.
Yeah, complexity is not our friend, and it certainly is increasing. Well, it's not like there aren't tools out there. This slide shows some of the common tools that are available in the AppSec landscape, everything from static analysis like SAS to dynamic security testing like DAS, looking at your dependencies and libraries through SCA, doing things in runtime, whether it's, real-time application self-protection, RASP, or it's using web application firewalls or SIMs, and IaaS, which combine some of these things together. There's lots of tools, right? So it's not like we don't have tools, and these tools are good. What do you see as kind of the major pros and cons of these different approaches, Tom?
I think I have to start with all of them have pros and cons. So I like to think of a defense in depth strategy to kind of get the best of all of them. SCA is a great tool, but it's only going to find things that we know about. So SCA by definition looks at known vulnerabilities in dependencies. So if there's a 0-day or something we haven't found, it's not going to find that. SAST is great. It's going to find a lot of things, but you also get a high number of false positives with SAST. And if you're running SAST at the end of your release cycle, the number of findings is just going to be daunting for people to wade through, much less decide what are the real positives. DAST is a great solution as well. It can find issues in your running application, but on the other hand, the testing has to cover the code in order to find those things. So you get false positives. You can get a false sense of security that the software doesn't have flaws or doesn't have really exploitable flaws because our testing didn't cover that part of the code base. IaaS, again, is another thing that can find problems in your running application. It can have false negatives as well because the code has to be executed for the IaaS to understand that there's a vulnerability in it. So that can lead you to, we have insufficient testing, so we're not finding important things that we should be finding. And then RASP is a great tool because it's providing protection in your production environment. Really good for legacy applications that weren't built with security in mind. But the cons with that is that it does have some performance overhead, and there can be a lot of complexity in tuning it and making sure that it's giving you the right kind of coverage for the value that you're trying to put in it.
That's great stuff. And then there's obviously additional solutions around, web application firewalls that have been around for a long time, security information and events, and they have kind of similar, kind of dynamic in production issues as well. You mentioned defense in depth, and that sounds like a key concept, right? Which ones of these do you think are the go-to techniques or approaches that you want to combine together if you're going after a defense in depth strategy?
Yeah, so I always start with SCA. Most modern applications, web and mobile applications, are somewhere between 50 and 95% third-party dependencies, the total code in your application. So SCA really helps you discover if you have known vulnerabilities in the things you depend on. Along with SCA, I often turn on secret scanning. A lot of vulnerabilities and a lot of exploits happen because you inadvertently put your secrets out in your source code repository, which you don't want to do. So that is what secret scanning prevents. Then I think that in a defense in depth strategy, you just want to pick the next thing to use. It doesn't matter between the other tools. Everyone has their preferences, but any one of them is the right answer. But picking one of them, putting it in place, getting value out of it, showing that value to your stakeholders is the right thing to do. And once you get that from a defense in depth strategy, you just want to, once you start getting value, you want to pick another one, implement that, and start using it. So all those tools have value. You can layer them together and develop a defense in depth strategy going one at a time.
No, I like that. That makes perfect sense. And it probably also depends on your risk profile, your application domain, what kinds of issues you've seen before in production. A lot of times, unfortunately, it seems like security issues aren't well fed back into the process so that we can, look at what the issues or challenges or what the attacks are that we're seeing in production so we can figure out how to mitigate those in production.
Absolutely.
No, good stuff. Yeah, and a couple of other notes. Tom hit on some of these, but I wanted to really drill into them because they're important if you're putting together an end-to-end application lifecycle. Because we're talking about tools that work on code or work on applications that are, applications that have been built from code. But there's some challenges with that approach and only doing those things in your SDLC. The first is that there's a misperception that static code analysis is going to find all the vulnerabilities in your code. Yes, Tom mentioned there's false positives, so there's other challenges with SaaS tools. But the other thing to recognize is that defects in code is only one piece of the vulnerabilities that might be in your applications, because it's easy to find particular defects, like, I did something that's caused a SQL injection or a, cross-site scripting issue on my code. It's a lot harder if the problem isn't a particular piece of code, but it's the design and how it's structured, or the requirements and how they've been defined, that is the problem with your application, right? I always say you could take two things that are perfectly secure from a code perspective and put them together in an insecure manner. And we call those design flaws, right? It's inherently bad thinking around, how you're thinking about security in your overall architecture and design of your system. And static code analysis tools will not find those kinds of problems, or at least the majority of those problems. Some of the code analysis might find some of those problems. Have you seen that, Tom?
Oh, yeah.
In your analysis?
Oh, yeah, definitely.
Yeah, it's definitely out there.
In the end, security is a people problem, both in finding issues and resolving the issues. So tools can help, but you need people who understand the systems, how they're built, and how to secure them to make sure that you're building secure software.
Yeah, that's a great point. When it comes to dynamic security testing, Tom mentioned this, just like we have challenges in our functional testing, right? In QA and testing of our systems from a functional perspective. Do they meet the requirements? Do they meet the use cases that have been defined for our customers? It's very hard to test security late in the life cycle, because when you have a big system, it's kind of a needle in a haystack to find issues in it. And dynamic security testing has the same challenge. As we're trying to do things dynamically on applications that maybe are very large, depending upon how we're architecting our solutions, it's a needle in a haystack challenge in security as well. I assume you've seen those challenges as well, Tom, with dynamic security testing and identifying vulnerabilities in it.
Yeah, absolutely. I mean, dynamic security testing can take a long time because you're crawling through the application, trying to follow every path. So usually you prune the path in some way, and then you run the risk of not finding something you should find. Sometimes you don't do enough fuzz testing in your dynamic security testing, so you're not hitting on the values that would trigger a problem. So you could get a false sense of security that we don't have vulnerabilities when we just haven't done enough of the right testing. And enough of the right testing could be exhaustive. So there are trade-offs you have to make.
Absolutely. The third is, if you're not doing much until you get to production, I would say that's probably not a defense in depth strategy, right? Because, if you're finding things in production, one is it's hard to find everything as attacks are coming at your application. And two, it's very late in the life cycle. And that usually means, some pretty costly rework or some, things that are revealed by customers or risks to customers if you're just doing things in production. Is that a fair statement in terms of the challenges with using kind of, solutions that are in production to mitigate risk?
Absolutely. And the other thing is that if you're working late in your release cycle, you are guaranteed to negotiate defects into production. Defects you know about, generally you try to make them the things that have the least impact, but still they are vulnerabilities that you're putting into production because you don't have time to remediate everything.
Yep, great point. All right, so what do you do about this? So this shows a comprehensive AppSec solution to consider. And as Tom mentioned, you're not typically going to do all of the activities shown on this AppSec, at least until you become very mature. But one thing we want to highlight, we've been emphasizing that tools can help us a lot, and integration of those tools, as we'll talk about when we talk about the GitHub solution, can help even more. But there's also some upfront activities that are important to consider if you're going to address application security, the design issues, and when you're testing, do things in a way that's going to be tractable. And those include really identifying and focusing time and attention on making sure you get your security requirements correct. So whether those requirements are around specific security controls that you're putting into your application, authentication, authorization, or encryption, or whatever those things might be that you feel like are necessary for your application to protect its data and its intellectual property, you've got to get those right up front. And some of them are also, what you would consider to be emergent security properties or principles. So things that aren't about a specific control or specific security capability, but just making sure that the application as a whole is secure. The next thing you want to do is take a hard look at your application and do what's called threat modeling, which is look at your architecture and design and your requirements and what you're trying to do, and start reasoning about the threats that might attack your system and whether your overall design and strategy for mitigating or protecting against those attacks is solidified or sound. And if not, we use the outcome of threat modeling to figure out, well, how do I then design things defensively? So make sure those design flaws that we talked about earlier don't end up in our application. And how do I code things securely and integrate security requirements into my process so that everything works properly when I get through coding. That's our goal in an application security solution, is both build in security as best we can. We'll talk more about that. And then go through and leverage technology and tools to help us, push good code out into production, right? That's our goal in this process. A question for you, Tom, is, so how do you get going with something like this? Like, where do you start overall? And how do you work in some of these early life cycle activities into your process?
Yeah, so I start by looking at what AppSec practices are in place already and build from there. So if you have no AppSec program in place, great places to start are just putting in SCA and secret scanning, using those as a way to get started, a way to start knowing what your security posture is. The one thing that I like to remind people too in a DevSecOps world is that ops part is very important as well. So starting in the beginning of having building security in is putting telemetry in place, some kind of security monitoring in place in ops so that you start that feedback cycle. Then I like to look at moving into other tools such as DAST or SAST, IaaS, RASP, putting them in place. And then the one thing that a lot of people forget to do is react to the findings. So you're going to start collecting data. Collecting data is interesting, but if you're not actually using that data, you're not going to get the benefit out of it. So one important thing to remember is as you start building security in, you have to react to your tools, start fixing the issues they're finding. And so that starts with first doing triage and then remediation. After we have practices there that are getting value, then I look at some of the other harder human factors that you were talking about, things like threat modeling, defensive design, secure coding, pen testing, getting people more involved and getting people learning how to leverage that kind of thinking in the software that supports it. And then you have to teach the teams how to create logging for application security and intrusion detection. Developers, I was a developer for a long time. Developers will only create logs for things that are going to help them debug either now or in the future. So without a requirements for AppSec logging, you're just going to get data from that the developers created for their own debugging purposes, and that can be hard to have a comprehensive security event monitoring system. So include those in your thinking as well. How do we balance the new requirements with making sure that we have the correct telemetry in order to provide the application security that we need?
Now, that's great stuff. And when you're ready to start thinking about some of these early life cycle things like threat modeling and secure coding, defensive design, one challenge that we've historically seen in the AppSec space is scalability of the team, right? People with security knowledge and expertise are usually historically been part of a security organization that is, maybe setting up some of these tools, running these tools, doing some pen testing, other things as part of your process, putting, things into production to monitor things. But that doesn't scale, particularly as you get more and more development teams that you would like to build better code. Can you talk a little bit about this idea of a security champions program that has become very popular as a way to try to infuse security knowledge into our development teams?
Yeah, so the idea is that you take your AppSec professionals that you have on your organization now and make them your AppSec evangelists. Part of what the evangelists do, along with telling your entire organization how to build applications securely, is identify champions, people who work with the teams on a day-to-day basis, who have a security mindset, are interested in learning more and getting better, and then teaching them how to create secure software, coaching them how to get other people to create secure software, how to review the code, how to triage and remediate problems. And you make them your security champions. They work on the teams themselves. And that way you're having people who you feel are interested in security, who want to be the person on the team who is always thinking of that as they're building out their software. And then you put processes in place to help your AppSec and to help the champions get your AppSec processes going and support them while they're doing that. And then you teach the champions and the team members how to use the tools and have ongoing security application security training so that they understand how to build software and keep reinforcing those skills. So the goal of the evangelist is to create champions. The goal of champions is to make sure that the application team is considering application security as they build out their products and build security into the software.
Now, that's great stuff. And we're going to talk in a bit about some of the GitHub products that support this life cycle and these activities. I do want to note that there are also some Microsoft products that complement those GitHub solutions, including the threat modeling tool that Microsoft has that we've definitely used with our customers to build and maintain threat models against risks in your system and trace mitigation of those risks into your application and into your code. That's a great solution from Microsoft as well. So let's talk a little bit about how we can leverage GitHub capabilities to do AppSec across our SDLC. And these are some of the different areas that are available from GitHub that we use in our practice. And in a minute here, we're going to have you, Tom, talk a little bit about each of these and what they provide. And then we're going to show some demos of activities. So, first up is GitHub Advanced Security, which provides us a set of components to help us secure our applications during our process. You want to talk a little bit about what GitHub gives us, Tom?
Yeah,
from an advanced security perspective?
Yeah, GitHub Advanced Security does a couple of things, one of which is secret scanning. So if you have any secrets that are in your code base now, it will find them and help you remove them, remediate them. You also want to turn on push protection, which will prevent people from checking secrets into your repository. So a common way people get exploited is accidentally putting secrets into their repository. And then having other people find that who then try to leverage that to break into your systems. So the best way to prevent that is not letting those secrets get into your repo to begin with. The next is Dependabot, which is a SCA tool that goes out and it looks at your dependencies and helps determine if those dependencies have known vulnerabilities in them and tells you about that. Leveraging that with GitHub Copilot, they also can help you build pull requests to update dependencies so that it makes it easier for you to just deal with all those problems. And then finally, CodeQL is a static analysis tool that will look at your code base and try to determine if there are known security patterns in them. The example I always use is SQL injection. SQL injection is a great example of something that we've known about for a long time. So we've been using SQL for 50 years. We've known about SQL injection for about 49 of those 50 years. And yet people are still building code that has SQL injection vulnerabilities in it. CodeQL can help you identify those and remove those. And again, paired with Copilot and Copilot workspaces, it can help you quickly remediate those.
Cool. Yeah. So you mentioned Copilot a couple of times. Can you talk a little bit about how Copilot integrates with GHAS and what kinds of capabilities that gives you in the GitHub ecosystem?
Yeah. So the way that Copilot interfaces directly with GHAS is that when you have a GHAS license, you can use Copilot to, after the GHAS components have found vulnerabilities, you can use Copilot to suggest remediations. Sometimes it's very proactive. So a lot of Dependabot issues that you find, Copilot, the GHAS will use Copilot to come up with a fix and create a PR, a pull request that you can just go review and run. The GHAS will rerun your tests with the changed code. So it creates a branch. Part of the PR is creating a branch so you can run all of your tests and it'll tell you, did all your tests pass? If you have a lot of faith in your tests, that means you should have a lot of faith that you can merge that PR without a lot of problems. Since it's a PR, you also have a lot of opportunity to go in and review all the code changes if you're concerned about those, or you probably should be concerned about them, but it makes it easy to review those and then accept that pull request and merge it into another branch or your main branch.
That's great stuff. And we are going to demo that for everyone on here in a minute. You want to talk a little bit about this newer capability, which is Copilot Workspace, and what Workspace is all about and how that can be leveraged in an AppSec program?
Yeah, so what Copilot Workspace is it allows you to use Copilot to form a plan for an issue and then use that plan to actually make code changes, usually with multiple files, and then allows you to review those changes and decide if you want to commit those, create a PR for them, and push them forward. So the idea is that you are using AI to help you from a AppSec point of view. You're using AI to help you more quickly remediate your issues. A lot of the problems that we find with our AppSec tools are things that have known fixes, and Copilot Workspace can help you plan out those fixes, implement those fixes, and get them into your code base quickly.
That's great. And that's what you just mentioned. It's also related to campaigning, right? Or GitHub Copilot campaigns or GHAS
So the idea
campaigns,
of
which lets you kind of attack a particular area. You want to talk about that too?
Yeah, so what campaigns allows you to do is it allows the AppSec team to say, you know, we're going to focus all our organization on fixing a certain type of problem. So SQL injection is a good example. We have some SQL injection vulnerabilities through our suite of applications, and we want to spend a period of time, create a campaign around that. It's much like a marketing campaign where we're encouraging people to go out and fix those problems. Could be setting up help to remediate those problems, but the goal is to rally people around fixing a certain problem so that we don't have those anymore in our code bases.
Nice. And as we know, a lot of this stuff feeds into a regulatory requirements process. If you're in an industry that has regulatory requirements, a lot of times those are security related. Some of the GitHub tools are providing you capabilities and information that you can use to demonstrate that you achieve or meet regulatory requirements. GitHub Actions recently added some attestation type of information into the process to do what's called build provenance. Can you talk a little bit about what that is and how that fits into what we're talking about here?
Yeah, so the idea of provenance and attestation is that you have things that you want to be true about your software in order to be compliant, and you have to prove that and show why it's true. So PCI is a good example of a pretty well developed application security requirement where you're basically, the goal of PCI is to make sure that the way you process credit cards is secure and the way you handle the data of the credit card for your customers is secure. So the audit process is talking about how we comply with the requirements to be secure, and then attestation, if I can say it right, are
Attestation. Yep.
attestations are saying this is how we do it, and then provenance shows how we go from the controls we have into the audit to show that we've actually complied with those. So it's a way of maintaining the integrity of that process and showing that you are compliant.
Yeah, and I know that GitHub Actions and their attestation capability integrates into some secure storage solutions as well. So some ways to make sure that as you collect up that information, you're storing that in a way that can't be modified, which is another key requirement of most regulatory requirements, is that there's some protection around the results such that they can't be tampered with. So that's a nice feature in the GitHub ecosystem as well.
It is. Yeah, I mean, that's
awesome. Go ahead, Tom.
No, go ahead. Sorry.
I was just going to say, anyone that's interested, please put your comments in the comment block. We're going to jump into some demos and show some of the capability that Tom's been talking about. If you could switch over to Tom's screen so he can show some things, that would be great.
Let me. Okay. So what this is this is a an application that we've built, and what I did was create a branch just to show in this demo, and we turned on issues, which is kind of our gateway into Copilot workspaces, and then we turned on the application security, the GHAS different products, so Dependabot, CodeQL, and secret scanning, and that created a bunch of results. So we have some things in Dependabot that are issues, and they range from critical to high. So let's click on one of these and go in, and you can see that the recommended change is to update our version of COA, and you can create a security create a Dependabot security update, which would create a PR. We should have some PRs already. They didn't make any PRs. So why don't we go ahead and do that?
And Dependabot, Tom, is your dependency analysis, right? So you mentioned SCA earlier. This is GitHub's solution for making sure that your dependencies that you're integrating into your applications don't have known vulnerabilities in them.
Correct. So this is GHAS using Copilot to create the file changes to make sure that we're putting the proper versions in place and upgrading those. It's going to take a minute or two to run.
So while we wait for that, Tom, I mean, you've used this on customer situations. You've used this with people. What's your assessment of the benefit and usefulness of having this capability over historically having getting vulnerability results and then having to weed through those and figure out what to do and triage and fix them? How productive is this approach using AI?
Yeah, so for a lot of particularly your dependency issues, this really short circuits a lot of the work that you have to do to go figure out what's the right thing to do, why we have this problem, and then creating a patch for it. It goes from taking a long time to do that to cannot update Mongoose. So let's go back and pick a different one.
What's a demo without a challenge, right?
Let's see what this one has.
No.
So hopefully this one will work.
Cool. So as you were saying, go ahead.
Yeah, it really short circuits the time that it takes to fix a lot of your issues. It's more like delegating it to someone on your team who's going to go do that research, update the files, and then give you a PR to merge it. So it's like having a junior person, capable junior person, come on your team and be able to do all that work. So it helps you spend a lot less time remediating your issues.
And I know one of the challenges, and I'd be curious to get your perspective on how this approach helps, the GitHub approach helps, is when you talk to developers about why they haven't updated their dependencies, right, or their libraries, if some issue is in there, it usually gets down to it's not as simple as just using a new version of a library. Oftentimes the changes mean you have to modify your code, right, or do other things to your application which you didn't plan to do and you might not have time to do.
Right.
Does this solution help with that problem?
So what we'll see using GitHub or Copilot workspaces in a minute is using that to make all those changes. So we can see here with this pull request, we have just fewer things that we have to do. It ran the checks and there's no conflict, so we could just merge this now. But let's go look at that specific problem. So CodeQL found some issues. So it found this use of externally controlled format strings. And we can see that could be problematic because this is much like the log4j error where you could potentially have any command running on your server because you could do some kind of command escape. So we start by creating an issue for this problem. And we go ahead and create it. And then we're going to open that. So this button here is open in Copilot Workspace.
So what you're saying, Tom, is in order to use Workspace, you need to basically create an issue that you can open, and that kind of starts the Workspace process. Is that how it works?
Yeah, that's how it currently works. There are plans of adding the ability to open things in Copilot Workspaces and other parts of the user interface. So first, we've done some brainstorming, and what Copilot does is look at the problem, come up with some proposed solutions. If we look at these and decide that we like these, we go ahead and generate a plan. And then if we like the plan, if we decide this is what we want to do, we can go ahead and implement the selected files. And then Copilot's going to go ahead and make changes to those files. And yeah, looks like it made them pretty quickly today. If we like those, it's going to check them into a branch, and we'll go ahead and create a pull request for all these changes. So you can see here, you can go through and look at, these are all the changes that it made. So the things in the cross marks here are things that were removed, some specific problems, and then things that were added. The green on the right side are things that were added in places where that line doesn't have a corresponding other line. So we just create a pull request here. And so this is fixing that problem, and you can see that Copilot's working over a number of different files. So we're going to go ahead and open up that pull request here. And what it's doing now is running some of the security check, or some of the testing checks that we have, making sure that we're not introducing other problems, that we're not introducing conflicts, running our tests so that we have a good feeling that, if we have faith in our tests and we believe that we have at least a branch that can go on to be merged and fixed and tested in our main branch.
That's great. Well, that's running, Tom. I mean, we teach an AI for testers class at Coveros, one of our most popular AI classes, and it talks about how you leverage AI capabilities to improve your overall software testing process. What I love about what you're showing is in that class, we walk through using, either chatbots or Copilot, in maybe your IDE or whatever it is you're doing to march through this process that you're describing. But you have to do a series of prompts yourself and keep track of the results and kind of string together this process that you're showing. Whereas Workspace does all that for you. Is that really what we're hearing out of what Workspace gives you?
Yeah. So it's helping you go through that same thing you'd have to do with your chatbot or even with Copilot Chat in a more organized manner. You can see all the results, all the things that it's done, and you're getting the same. I mean, it's using the same LLM to find all these things. It's just helping you create the prompts, helping you plan what files you're going to change, and then helping you change those files and then running the test. So it is helping you do the same thing you would do otherwise, just in a more defined environment. So as you can see, we passed all our checks. I have a lot of confidence in my checks and my build pipeline. So I'm going to go ahead and merge this. And now and as per the GitHub flow process, we're going to delete the old branch. And so now I have all these fixes in my application. When the application reruns the scan, we'll see that we have those vulnerabilities addressed. And
That's great stuff.
You can see here, we've pushed to master. So now we're rerunning some of these scans, and it should update when it's done. It should update my security results.
What is your thought, Tom, on, we talked about threat modeling and doing risk analysis and whatnot. Do you think that just based on what you're seeing from Copilot workflow, that workflow potentially could be used to help you kind of think through your threat modeling activities and your risk activities, integrate in with, Microsoft's threat modeling product and things like that? What do you think about using this product as part of that kind of build it in approach?
Yeah, I think that's a great idea, right? So that's why GitHub created Copilot Workspace, is to help you do all the work that you need to build software and create a product. So anything that you would do to conceptualize your product, create requirements, and then put the code together, create tests for the code, you can do through Copilot Workspace.
That's cool.
And that includes your application security work.
Cool. Thanks, Tom. We had a couple of questions or comments. One was from Noel. This seems absolutely awesome, how developers waste time with dependencies that are not actualized. I'm glad to see that we're addressing this. Yeah, it's a great concept. Someone else said, Fuel Snabble said, I will ask Copilot agent to take over my future security incidents so I can write code instead. What do you think about that? Does that make sense to you, Tom? And where's the line as well as to what we want these tools to do versus what we feel like we still need to own as a professional? What do you think?
Yeah, I think that that the AI is a good tool. It's not a good thing to take over or control anything. So I don't know that we want to turn everything over to the AI. The human beings still need to be in charge. But leveraging AI to make yourself more productive is certainly something that we are going to do. A lot of people are doing now, and it's going to become more prevalent. So there was kind of this a saying about fire is a good servant and a poor master. I think AI is the same way. As long as the people stay in control, leveraging AI to make yourself more productive, great. Turning things over to AI, letting AI make all the decisions, not reviewing the work that it does, is probably a mistake.
Yeah, that's what I love about the GitHub solution is you march through that, Tom. It's showing you what it's thinking. It's showing you, well, here's what I'm thinking a good plan is. Here's what I'm thinking the changes need to be. And it's giving you, as the subject matter expert, the ability to review what the thinking is and either accept that thinking. In this case, it made sense. Or sometimes, as you know, sometimes what it's thinking, you go, I don't know about that. Let me try that again, or give it a different, or give it some more context, because what it came back with, I'm not sure is the right answer. Is that how you're envisioning these tools best be used?
Yeah, so you want to leverage it. One of the good things about AI is that if you don't like what it's done, you can tell it to try again. You can give it further instruction in the prompt to help it understand what you don't like or what didn't work right. The other thing is it can give you, for code changes, it can give you a good idea of the code change, and then someone who understands how to write programs, it's a lot easier to go in and change to make it be a little bit more what you want. So sometimes you'll accept a change knowing that you're going to have to fix it a little. And then just to try to close this work cycle. So we've introduced and checked in the code. So we're going to go ahead and close this issue. And then we've remediated a problem that, looking at the number of files that it changed, probably would have taken you a couple of hours to do in 15 minutes.
That's pretty productive. Awesome, Tom. Thanks. You want to switch back to the slides, please? All right. So just a couple of thoughts before we leave today. One is that we have another partnership besides our GitHub and Microsoft partnership with a company that also integrates in as a technology provider of GitHub, and that's Fianu. For anyone in the regulatory space, Fianu works with GitHub Actions attestations to add additional attestations in out of the box. It integrates in So as you're using actions and using your other GitHub tools, it can be automatically enhancing your automated governance process and saving all sorts of control gates that you can set up to capture even more provenance about what's happening in your process and what security analysis has been done, testing analysis, things like that. So if you're in the GitHub ecosystem and you're interested in automated governance, check out Fianu as well. In terms of how Coveros can help, for those interested, contact us at the URLs that have been streaming by at the bottom of this website. We have lots of great services to help organizations putting in place better application security using the GitHub platform. We have a great GHAS Getting Started bundle that helps people get off the ground. It's a combination of coaching and training. We have a Copilot adoption program if you're looking to adopt Copilot, either as a code assistant or integration into GHAS and some of the things you saw here with Workspace. We have an automated governance solution that helps organizations put in place tools like GitHub Actions, like Fianu, other tools, figure out what the gates are, automate the whole process so you're getting out of the business of doing manual compliance checks and analysis and automating that process. We do lots of maturity assessments to help organizations determine how mature your DevSecOps process is, where you need to improve, how mature your AppSec process is, where do you need to improve. And then we also do security testing and remediation for clients who are looking for that kind of support. Anything you want to add to that, Tom, before we take additional questions?
No, I think that's a great overview of how we can help. Thank you.
Awesome. Any other additional questions before we wrap up? We do have a few minutes left. If anyone has anything they want to throw into the chat. While we wait for that, Tom, is there any other things that you want to mention about the GitHub solution and how to best support a AppSec program with GitHub? Anything else jump to mind?
I mean, one good thought is to keep in mind that all of the GHAS features that you see in GitHub are also available in Azure DevOps. So if you're an Azure DevOps organization and you're interested in security solutions that are built into the platform, you can use the GHAS in Azure DevOps. We often call it GASDO since it's GHAS in Azure DevOps.
Yeah, that's a good point. You also, if you want to get started and you're currently using some other tools, maybe you've already got a SaaS tool or whatnot, and so part of the GHAS solution is something that you're using other tools to do or to use. GitHub recently announced, and it has been made public in the last couple of weeks, that they're unbundling the various aspects of GHAS, so the secret scanning, the CodeQL, SAS scanning, the dependency analysis you can now purchase and use individually. So if you're using a SaaS solution, but you don't have a good secret scanning or dependency analysis that you like, it's a way to start leveraging this great platform and what Copilot gives you around that platform. Also, if you're thinking about migrating over time to a GitHub platform and a GHAS solution more comprehensively, it's a great way to get started, start using some of the capabilities, and then over time, as it makes sense, migrate to it. I think that's a pretty hot idea, Tom. I don't know what you think in terms of this recent announcement.
Yeah, I think it's wonderful. Secret scanning built into the platform, which is what the secret scanning gives you with GHAS, is a wonderful way to get started and maintained. It's something that's going to be there, supported by GitHub, so that you don't have to worry about making sure that you're maintaining something. So I like to have as much maintained by the platform that I'm using as possible, so that we don't have to worry about that. We just get the benefit of it.
That's great. There was a question from, is it Arton? Can the dependency review detect malicious updates in open source libraries?
So once that it's known and it's been published, so all SCA tools use the National Vulnerability Database. So once it's been discovered and put in the National Vulnerability Database, then yes, it will find those. It's not going to find 0-day things where no one knows about it yet, because it relies on having someone, some security researcher or some person finding it and then getting it published. But no
Yeah.
dependency, no SCA tools will find things that aren't known.
Yeah, I think that highlights the importance of working some at least lightweight threat modeling into your process. Because, as you know, Tom, as you're going through and looking at, well, what are the risks and what I'm doing with my application, my design, my architecture, how things are structured, how I'm integrating components together, this risk that's Erton mentioned is exactly one of the things that threat modeling can help you think through is, well, what if this particular component is malicious and it's something that hasn't yet been discovered? How do I make sure in my design I'm mitigating that risk and protecting that risk? And then how do I test when I get to testing to make sure that that particular challenge has been mitigated? That's exactly the reason why you want to integrate some threat modeling into your process. And we do have, by the way, I didn't mention it on the last slide, a great threat modeling workshop that we provide. We also have a threat modeling class for those that want to get going with threat modeling. If you're interested, happy to talk to you about how we can help you get off the ground.
There are organizations that, particularly with open source libraries, create a fork of that, update it when there's a new release that comes out, and then use their own SAST and DAST tools on those to try to find something like a malicious update. A lot of those are security researchers who do that, but that is an option if you're very concerned about something like that happening. And frankly, it could happen. It has happened a number of times in the last few years where some widely used open source library did have a malicious update.
Yeah, and back to your original point about how much easier it makes the whole process of updating your libraries when you do identify there's something that's wrong in that library. I mean, it gets back to Equifax and some of the other issues that we've seen in the past where a vulnerability was known to be in a library that was sitting in, in the application in production, but it was never prioritized, maybe deemed to be too hard to do to update right now. And so it got pushed out. And unfortunately, an attacker found that issue and exploited that issue in Equifax before it actually got fixed. I mean, that's what these kinds of tools are trying to prevent, right?
Absolutely.
Derek asks, what's the best way to recover two-factor after it's lost?
It depends on how the two-factor system works, I would say. I mean, usually it's if you know who the administrator is, working with them.
And with GitHub on dependencies, how would you go about a library that's been deprecated? How do you deal
so we do see that where there's a library. Usually what deprecated means is that no one's working on it anymore, and then a new security vulnerability is found for it. And so there's, I see two ways organizations handle it. One is they fix it themselves. Um, you know, hopefully they release that back to the community if they can. Some libraries, um, the maintainer's gone silent, so you have to fork it and create a new name for it to give back to the community. The other is to replace it. Sometimes that can be really hard to, depending on how much functionality you use, it can be really hard to replace that functionality, particularly in a short period of time. I guess a third too is just to accept the risk. If it's a low impact issue, um, most likely you're going to accept the risk for a lot of low impact issues anyway. So um, I would look at it if it's like a medium, high, or critical, either trying to fix it and give it back to the community or replacing the functionality. And if it's low impact, you're probably going to accept the risk.
Awesome. Well, Tom, thanks for being on today and answering all those great questions. I know we are out of time. I want to thank everybody that tuned in today. Definitely share this Reactor with other people. Like it, and definitely reach out to Coveros if you'd like some help. Thanks, everyone, for attending.
Thank you.
Thank you all for joining, and thank you to our speakers. This session is a part of a series. To register for future shows and watch past episodes on demand, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. We'll see you at the next one.